Hello. Today is another review topic that is important through all levels of math, especially going into calculus, which includes writing parallel and perpendicular lines. So we're going to write the equations of the lines parallel and perpendicular. So that means we need to come up with two different equations. We need a parallel line and a perpendicular line to a given line, and our given line is 3x plus 6y equals 12 through the point -4, 1. So what's going to happen in this video is I'm just going to show you how to write the parallel line and how to write the perpendicular line. Then likely you are going to have an Edpuzzle where there's going to be more practice in doing this afterwards. So we're just going to get right to it. So the very first thing we need to do is we need to change the standard form 3x plus 6y equals 12 into slope-intercept form, y equals mx plus b. We need to do that for two different reasons. Number one is we need the slope, and number two is eventually we are going to graph this. So we want to make sure that we have the equation so we can graph it as well, so we can see all the pieces. So I'm going to start by taking that equation. I'm going to subtract the 3x on both sides. So we get 6y equals -3x plus 12. Then I'm going to take this, divide everything by 6. If you notice, I'm dividing each term individually by 6 instead of just doing one big thing over 6. This will alleviate some of the errors that people make when they try to do it all at one time. So what I'm going to do now is I'm going to graph this equation and then also the point we're looking at, so we can have a firm idea of what this graph looks like and what we're trying to end up with. So we're going to have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I want to remind you that it probably would be better to graph on Desmos, but for the sake of this, it's easier to see it right here. So we're going to go to our y-intercept is at +2. So we get +2 right here. Then our slope is -1/2. So down 1 and to the right 2, down 1 and to the right 2. And this is going to get us our line of y equals -1/2x plus 2. We're now going to look at our point that we have. So we have that secondary point at -4 and +1. So what happens is that when we look at this, our parallel line should end up going down in that same sort of direction. I'm just kind of making it dotted a little bit so you can see where it's going. And then our perpendicular line should make a 90-degree angle and should come up this way. Now, the reason I'm showing you this is for you guys to see that our y-intercepts in the parallel and perpendicular line are not at the same location. That is one of the things that people have some errors with, is assuming that you're just going to have the same y-intercept and you just change the slope. So that's not true at all. So what we're going to do right now is we're just going to look at the parallel line. So to write the parallel line, what becomes important is we need to know what our slope of our parallel line is, and then what is our other point that we're going through. Well, our point is -4, 1, and our slopes of parallel lines are the same. So that means our slope of our parallel line is going to be the same as the slope we found in the original line. So it's going to be that same -1/2. So when we have this, what we're going to do now is we're going to write our equation. So I'm going to use that point slope form. Y minus k equals m times x minus h. This is the formula that we gave you yesterday finding the writing equations of lines. So that means we are going to have y minus 1 equals -1/2 times x minus -4. So now from here, the two negatives make a positive, and we're going to do the distributive property. So we're going to get y minus 1 equals -1/2 x, and then this will become -2 because half of 4 is 2, and then we can add the 1 to the other side. So that gets us y equals -1/2 x minus 1. Now what this shows me is that my estimate that I drew was a little bit off, and it should actually have a y-intercept at -1. Our slope is -1/2, so down 1 and over 1. And if we do that the other way, then we'll see that it does end up lining up perfectly. So this is why it's critical that you actually write the equation and solve it, and you just don't estimate. So y equals -1/2 x minus 1 is our parallel line. We're now going to go through and find the perpendicular line. So before we can do that, we need to think about the slopes of perpendicular lines. So for the perpendicular line, our slope is the negative reciprocal. So what does that mean? The original had a slope of -1/2. So that means our perpendicular line is going to be the opposite of this, which makes it positive, and the reciprocal, which means it flips over. So our perpendicular line slope is y equals 2/1. So using our slope of 2/1, and our point is still -4/1, we're going to use that same point slope form. Okay, so we're going to use that same point slope form of y minus k equals m times x minus h. So this is going to get us y minus 1 equals our slope of 2 times x minus -4. Change our signs, do the distributive property, so y minus 1 equals 2x plus 8. And now if we add the 1 to the other side, we get an equation of y equals 2x plus 9. So this is our equation for the perpendicular line. So now let's test that out. So what we can do is we can go up to +9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks kind of close. And our slope was 2. So we can go up 2 to the right 1. Or we can go the other way, down 2 to the left 1, 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 and then we have the value that will connect it. Now, clearly I did not do a perfect job in drawing the line. That's why using Desmos is actually a better way to graph. So this is y equals 2x plus 9. But one of the things to realize is that you should have 2 right angles. So now go ahead and you're going to have some problems on either quizzes or Edpuzzle to try.